Hello everyone and welcome to day 7 of Kaggle's 30 Days of Machine Learning Challenge. And today, this is the last day of Python. So today, when we finish this exercise, we are going to get a certificate for Python. Let's see what we are going to learn today. Today we are going to learn about imports in Python and get some tips for working with unfamiliar libraries and dig into operator overloading. Okay, fine, let's start with imports. So when we started with the Titanic challenge, that was like on day 1, we did a lot of things, and one of the things was to submit to the Titanic challenge. And if you remember, we imported a bunch of stuff, bunch of libraries like scikit-learn and pandas and whatnot. So, um, this is same as that one. So here in Python, you have a lot of standard libraries. So like math is a library, and math will allow you to do like things like take log, take exponential, so all the mathematical operations. So so there's high quality custom libraries that people have written. So let's say when you write a function and you think like you have written something that can be useful for many other people, you convert it into a Python library, and so I can use it, and anybody else can use it, right? So that's what libraries are. Libraries have a name. Math is one of the standard libraries that Python has. It has a lot of standard libraries, and you will learn about them when you work with them. So let's try to run this cell and see what happens. So now, when you print the type of this thing that you have imported, the library, it has a type class module. So I talked about f strings. So let's also convert it to f string and see how easy it is. Okay, so it gives you the same output as dot format, but it's much easier. So math is a module. A module is a collection of variables, a namespace defined by someone else. So like if I write I can write a library, but it's not going to be a standard Python library. It's not going to be included in the Python distribution, but you can download that library and then you can use it. So I can define the variables in it. So we can see all the names in math using the built-in function dir. Okay, let's print. So these are the built-in functions in math. So some have weird names like underscore doc. Then you have acos, acos-h, asine, log1p, log10, log. And if you want like so if you want if you want to know more about these functions, what you can simply do help and math dot is close. So it gives you help about the functions, the variables inside a module. So it's close determines whether two floating point numbers are close in value. So yeah, it is like that. So you have acos, you have acos-h. So these are all the math functions that you have. Arc, cosine. So here we print pi to 4 significant digits. Okay. Okay, yeah, sure, fine, math.py. Okay. But most of what we will find in modules are function like math.log. I've already shown you. Yeah, you have the help for math.log. You can you just have to write number and base. If you don't write the base is e. So it returns the natural logarithm of x if you don't specify the base. So yeah, it is things like this. You can have help on the whole module itself, and yeah, this is going to be huge. And now there are many different ways in which you can import stuff. So if I can write import math as empty, and then when I have to write pi, I can do empty.py. So So I can also write from math import pi, and then I can just do pi. So things like this, I can I can do that. If here I just imported pi, and now I can import math. If I import math, I have to write math.py if I want to access functions. So if I do import math as Abhishek, then so you can import it as anything. And if I just want to use one function, then I will probably just import the pi. But the convention is like if you have a lot of functions to import, I would probably just do this. Anyways, let's move on. So the as simply renames the imported module. Okay, yeah, that's what I showed you. So now I import import a library math, and then I point empty to math. Okay, so this is also something that I can do. Okay, so here empty dot path gives you the same thing. And now one thing is importing star. I talk about it quite a lot. So here when you do from math import, so we did from math import pi. So I can also write from math import star and then or asterisk, and then it will import all the functions for me. But this is something that you should never do. You don't know what it imports, what the different functions are. You should always import what you need. That's it. And yeah, so I think I'm the bad news guys. So I will grumble at you for doing this. And yeah, I do have a point. So like this example, this is a very good example of why we shouldn't do that. So there is a library called Numpy or Numpy. So it doesn't matter how you pronounce it as long as you know what it does, right? So if I do from math import star and another library for numeric Python, I do from Numpy import star, and then the thing is the variables from here will be replaced by the variables from here. So now here you get an error. So like if I do pi, it doesn't it works, but if I do log 322, it doesn't work. So this will work if I import only math. So if I do this, it works, but now numpy's function has replaced the math function and it works differently. So here if you check help and say log, it's going to give you a different function, right? So math.log is different than np.log. That's what I'm trying to tell you. So from math import log, you get this help, and if you do from numpy import log, you get a different help. It's just because both these libraries have the log function, but they work differently. They have different signatures, different arguments, and that's why you should never import star. And it's also not readable. So if you import star from everything and then you give me your code to take a look at, I don't know which functions you have used and where they're coming from, right? So yeah, never do that. Okay, this is a huge help. Okay, so now it tells you import what you need and import like this. So from math import log pi And from Numpy, you can import a function called as array. So Numpy is also something that you will be using quite a lot. Okay, so here we check the type of numpy.random, and it has a lot of things. It contains seed, set state, shuffle, things like this. So what numpy.random, so whenever you want to know what a function does, you do help. So here it gives you, so in the description it tells you that it's a random number generator, and so and you can go through this and you can see how they also give you some information about the implementation, but you can also check how you use this function. So if I do numpy.random then I press tab, it will give me everything that's inside this. So I can see, okay, I have rand int. Now I get help of that. So it returns random integers from low to high. Low is inclusive, high is exclusive. So you can also provide a size. Okay, great. So if I want to use this function, I can do random.randint numpy.random.randint, and here I can do 1 comma and it returns me number. If I do if I write 5 here, it returns me 5 different numbers, which all of them are between 1 and 10, and it's completely random. So if you want to roll 10 dice, so what you can do is you can write from 1 to 6 and 10. Okay, great. Should be 1 to 7, I think, right? Dice is 6 numbers and 6 is not included. So anyways, the places you will go, the objects you will see. Okay, now there are many things that you will have to learn. So many different libraries. So Numpy is one of them. Then you have pandas. You have so let's make a list. So you have pandas, you have Numpy, you have matplotlib, you have scikit-learn, you have scipy. So these are some of the basic libraries that you should take a look at. So here we wrote roles, and now we get the type of roles. So now here you see it's printing something like a list, but it's actually a Numpy array. And that's why when you print the type, you get numpy.ndArray. So now you start using external stuff, you get new types. And that's what it's trying to say. And all the Numpy arrays have some they can have different functions. So like max, min, n bytes, toString, toList. So if I do, we can do roles.mean. So it takes the mean of all the values inside it. I can also convert it to a list using .toList. Great, get it? So if you don't understand it, let me know in the comment section. And I can also do roles.ravel. So okay, so this is a help. So let's see if what if I do roles.ravel. So it just gives me a flattened list of values. So you don't see it as flattened because it's already one-dimensional, but if it would have been two-dimensional, it just flattens it. Anyways, you can also do roles.shape. Here it gives you shape is 10. And if I do roles.ravel.shape, it's still 10. um, 10 comma. So this is just 10 rows, no columns. And there's also reshape. So if I want to reshape it to 1 row and 10 columns, it just reshapes it to 1 row and 10 columns. It still looks like this. So now you see 2 brackets, but previously you had just 1 bracket. So if you look here, I can just write it here, rows. So this is just 1 bracket. This means all these values are in different rows, but now you have 2 brackets. It means inside this array we have 1 row, and in that row we have 10 different columns, and they have these values. So that's what it means, and it's very useful when you're working with machine learning problems. These kind of things are very useful. So now with the help of roles, since roles is a Numpy ND array, n-dimensional array, it's going to give you help on the n-dimensional array object. So let me just hide it. Okay, now operator overloading. So these are expressions that you think are difficult to understand, but it's not. So you have a list of values and you add 10 to it. Now we have already seen that you cannot add a list and a number, an int, or a float, right? So let's do that. And here it says it can concatenate on a list, not in toList. So now what you do is you create a new Python object, and that object can do operations like this. So that's what operator overloading is. So you have created a new Python object. So here in our case it's numpy nd array, and which looks just like this. But when you add 10 to it, it's going to work, and it's going to add 10 to each and every element of the array. That's what it is. If I do multiply here, it's going to repeat this list 10 times, right? But if I do multiply here, what happens? It multiplies each and every element by 10. So you just change the way things work, kind of. And so now if we have to find out at which indices are the dice less than or equal to 3, we can just do some simple things like rows less than equal to 3, and it's going to give me the index where it's less. So it's because Numpy has implemented that. So Numpy arrays were designed this way, and Python lists were not designed this way. So that's it, actually. That's what operator overloading is. Don't confuse yourself. Just use this stuff. So now you have a list of lists, and if you have a list of lists, you can convert it to a Numpy array by calling numpy.asArray. So here you see you have one list, you have another list, and both of them are in one list. So your so you have X list. So let's see how X list looks like. So this is how X list looks like, and you have X. And how X looks like is it's very similar, but you have array in front of it. There are a few things that you can do here. You can see the shape. So now the shape should be 2, 3. And that is 2, 3. 2 rows, 3 columns. And let's write X again. And in this way, with the brackets, you can now index the elements inside the array. So you get the last element of the second row of Numpy array. If you want to get the last element of the second row, like this one, so indices always start from 0, you get 6. So if I just do -1, I get the last row. And if I do -1, 0, what should I get? 2. Great, 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 great. And these kind of operations you can do with list. And that's what it's shown here. You create a new object that supports these kind of operations. Okay, I won't go into this. I don't like that this is here. Since this is a basic lecture, it's I don't think this should be here, the TensorFlow stuff. But yeah, it is providing same kind of example. And with this, we are done. I've told you the libraries that you should take a look at. So it's not very difficult. You just go to Google, you search for Numpy Python or just Numpy, and you get to Numpy page, and there is something called documentation, and just go and start from what is Numpy and why should we use it. Very simple, very easy to understand, and documentations are the best way to learn. And yeah, you need to keep practicing. So now let's go to the final coding exercise. Very excited about this. After this, we don't have any exercises in Python, and we will start with the intro to machine learning lectures. So let's see what we have. After completing the exercise on list and tuples, Jimmy noticed that according to his estimate average slot payout function, the slot machines learn Python Casino. The slot machines that learn Python Casino are actually rigged against the house, and they are profitable to play in the long run. Okay, that's not true about the blackjack game though. But anyways, so. Starting at $200 in his pocket, Jimmy has played the slot machine 500 times, recording his new balance in a list after each spin. He uses Python's matplotlib library to make a graph of his balance over time. Okay, let's run this. So now you see that it generates a plot. This plot has been generated using another library called matplotlib. So you probably need to take a look at matplotlib. So now here they say that you have to do a few things. So it's about learning the different functionalities of matplotlib actually. So he has a bit of bad luck. He wants to tweet this along with some choice of emojis. But as it looks like around his followers will find it confusing. Obviously, there is no info here. I don't know what the x-axis is, what the y-axis is. And there is the title is missing. So here it says, okay, add the title, make the y-axis start at 0, add the label balance to the y-axis. Okay, so I have to check a few things. So if I do help of graph, do I get something? Okay, yeah, I do get a lot of things, and it should have set underscore title. So yeah, it has set title, and it says set title for the axes. Okay, how do I set title for the y-axis? So now you have to go through the help and try to find it on your own, or what you can also do is you can also Google it. So if you just Google matplotlib set title y-axis, you will get something like, let me just go up. Okay, that is a huge help. So you will get something like graph dot. So if I just write graph dot and then I press tab, it should give me everything inside the graph. Okay, it's not giving me anything inside the graph, but like if let's write here, and yeah, now it gives me everything inside the graph that I can use. So let's see, what do I have? Y underscore So here you can also search for different functions and see what fits. So here, like, you have X text label and you have X label. So add the label balance to the Y axis. So it should be get Y label. Let's see. Let's try this one. So graph dot get. No, it should be set by. Again, I've come here and I cannot check it anymore. So let's see. I have legend. I don't have label. So maybe it's inside set underscore label set underscore y label. Okay, yeah. So should be set underscore y label. So now you see, as a beginner, I had some difficulties finding where how to set the label, and now I can write here balance. Okay. So is my job done? No, it's so here it says balance and set title is given to you, but my axis doesn't start with 0. So I have to change the x-axis. So sorry, y-axis start at 0. Y-axis should start at 0. And again, we have to find how to do that. So I'm thinking everything should be inside set underscore y. So this looks like something that can do our job. Help on this, set the y-axis limit view limits. Okay. Okay. So I can do graph dot set underscore y lim. And then what did we have here? Bottom. Bottom equal to 0. So let's see. Now the y-axis starts at 0. You can also set the same for x-axis if you want. So let's see. Here it says left instead. And if I just copy this one, xlim, and here I write left. Now both my x and y start with 0. So you can see, like, balance was 200, that jumped to 250 at some point, and then it jumped to around 300, so it's a little bit more than that maybe, and then it dropped to 150. So these on the y-axis you have the balance, and the x-axis you have the games, I think, the slot pulls. So now here in the bonus part it says, can you format the number on the y-axis so they look like dollar amounts? Maybe. So it should have a function, if I remember correctly, y tick labels. Yeah, this one. So let's see. Here we have the labels. Okay. So what we can do is we have 0, 50, 100, right? So we can just write graph dot set y tick labels, and my labels will be from 0 to 100 to 300. So with a gap of 50. So 0. So I can write x for x in range 0, 350, 50. So now I've used list comprehension to generate the string for me. and here I can convert it to a string, or I can just use f string here, f, and inside this I have dollar and x. Okay, cool. It worked. If it works in the first try, it's amazing. Anyways, so $0 to $300. So now you're also done with the bonus step. Check your answer, run this code cell to receive credit. Okay, now to receive the credit, you have to run this. Okay, they also used like this. Nice. But they used format. We used f strings, which is the same. Don't worry about it. Okay, so now what we have to do is, this is a very challenging problem. Don't forget that you receive a hint. Okay, Luigi is trying to perform an analysis to determine the best items for winning races on Mario Kart circuit. Okay. He has some data in the form of dictionary. So you have the key is name, then you have the name is Peach, then again name, then name is Bowser, name is nothing, name is missing. Okay, and the other key that you have is items. So it has some different items, and then you have another key, finish, which is an int. Okay, so that's all we know about it. I have not played Mario Kart, so I don't know what all this is. Items is a list of all the power-ups, items the racer picked up in that race, and finish was the placement in the race. 1 for the first place, 3 for third. Okay. He wrote the function below to take a list like this and return a dictionary mapping each item to how many times it was picked up by first place finishers. Okay, so you are given this list of dictionaries, and inside each dictionary you have information about a racer. Now, if the racer has finished in first place, return a dictionary mapping items to the number of times those items were picked up by racers who finished in first place. So if the racer finished in first place, you create a new dictionary and say, okay, these are the power-ups that were picked by the racers, but only those racers if they finish in first place. Okay, so now it says this is the function. Okay, so they gave you the function. If you want to take a look at it, but we move to the next one. And he tried it on a small sample and it seems to be working fine. However, when he tried running it on full dataset, it crashed with type error. Okay. Now it runs on the full dataset and it says can only concatenate string, not int, to str. Okay. So here it's like here this has been written using format. Let's write it using f string again. Len of racers, and then you have racer name. Okay, and remove dot format. Let's remove dot format and see what we have, and let's run it. Something is wrong. Oh, I didn't close this print. Okay, so now here I'm still getting, if racer name is none, I'm getting can only concatenate string, not int to string. Okay, let's see what it means. Now, like, if you look at this error, which is also known as the stack trace, trace back. So here it goes to this function best items, and then it passes full data set inside it, which is here. And you get error in the print. Okay, let's start removing stuff from print and see if it works. So if I just remove this one, this variable, it seems to be working fine. And if I remove this whole thing, it seems to be working fine. So previously it didn't work. So probably it's somewhere here. So if I remove this one, can only concatenate string to, okay, so you get the same error. And now if you do it in a smart way, you see that it's a concatenation error, and this is the only place that you're concatenating. So what could go wrong? Now we have to dig into the code. So let's start with the first one here. They define an empty dictionary that's going to get filled up. And now we go through each and every racer. So we say for I in range, the length of racers, which is a list of dictionaries. The ith racer dictionary is racer. So current racer is racers I, okay. If the racer finishes, go through all the items. So it says for I. So now this is the mistake here. So here you see they have used the variable I to loop over all the indices of the racers, and they have again used the same variable I to loop over all the items. And yeah, let's just change this one. So this I here, the I that was here, is local to this for loop, and here this I should be this I. So now that's the problem here. Maybe some item is a string and it's not able to combine with one. You can also check it like this, print I. So let's go through all the, so now you see first I that is printed is tree, the second I that is printed is red shell. Okay, so now we change this I with another variable, and now this should work fine. Okay, full dataset doesn't have many values either. Anyways, so now it is working fine. So you have successfully learned how to debug code, and we didn't need to use the hint to. So now the third problem, so I hope it's the last one. Yeah. So suppose we wanted to create a new type of type to represent hands in blackjack. Okay. One thing one might do with this type is overload the comparison operators greater than, less than, equal to. So okay, so this is hand one, and they have created new class. New object, blackjack hand, and inside that you have king and ace. So you have a list, and you are creating a comparison. So hand one greater than hand two. So defining custom classes is it's not in the scope of this lesson, but the code we are going to write in the function below is very similar to what we have to write if we are defining our own blackjack hand class. We put in __ gt magic method to define our custom behavior for greater than. Okay, gt is greater than. So return true if hand one beats hand two, and false otherwise. In order for hand one to beat hand two, the following must be true. The total of hand one must not exceed 21. The total of hand one must exceed the total of hand 2, or hand 2's total must exceed 21. So these are the two conditions. Now here we have to create a function that calculates the score of hand 1 and hand 2, so a hand in general, and then compare those two to in this another function. Okay, so let's see. So I can start by making a lookup table for scores. Lookup table, and this will be a list comprehension here I can have f of some x for x in range 2 to 11. So 2 to 10. So this will, if I print this, okay, if I print this one, it looks like this. Sorry, this should be a dictionary. So it's so the string 2 goes to 2, string 3 goes to 3, and it's because these are represented by strings here. So let's update the table with some more stuff. So here, if I write J and it has a value of 10, K has a value of 10, and Queen has a value of 10. So one thing we still don't have is Ace, and Ace can have a value of 10 or 11 or 1 depending on the hand. It should be in favor of the hand. So now if I do, now let's go over hand 1 score, hand 1 underscore score, and let's set this to 0. And for item in hand underscore 1, so this is the first hand, and 1, we loop over all the item and we say if item in lookup table hand 1 underscore score plus equal to lookup table, and here I have item. So if it's not Ace, it's pretty much straightforward. If it's Ace, things become a bit complicated. So I can also write hand 1 underscore aces, which is also 0. So now if it gets an ace, increase the hand 1 aces counter plus equal to 1, and also increase the hand 1 underscore score by 1, and we adjust them later. Similarly, we do the same thing for hand 2. But before doing for hand 2, let's also write the adjustment for the aces. So now we say if or for I in range hand 1 underscore aces. So if hand 1 underscore aces is 0, this loop will not run. We say if the score, if hand 1 underscore score, so if I adjust the value of the ace, I will actually be adding 10 to it. Okay, so I say if hand 1 underscore score plus 10 is less than or equal to 21, add 10 to the score plus equal to 10. Okay, so now we have to do the same thing for the other hand. Okay, sorry about that. Okay, I don't know what I did. Okay, I converted to Markdown. Okay, so now we have to do the same thing too for hand 2. So instead of copy pasting the same code, what we can do is we can create a new function. Let's call it hand score, that takes one hand and returns you the score. So instead of 1, I can just remove 1 from everywhere, and it's score of 1 hand. Hand 1, hand 1, hand 1. Okay. And return hand underscore score. Okay, so h1, let's represent hand1 score by h1, and hand score function, which takes hand underscore 1. And similarly, we have h2. So now we don't have to write a lot of code here because we have created a helper function. And return. So let's say if h1, so now we have the condition, right? So the conditions are total of hand1 must not exceed 21. Okay, if h1 less than equal to 21, and now we have two more conditions here. Total of hand1 must exceed hand2, or hand2's total must exceed 21, and h1 greater than h2, or h2 greater than 21. Return true, else return false. Okay, so we get okay, lookup table is not defined, so we get an error. So this one should actually be here. And we get another error. That means we have to debug our code. So it's only one function. So let's start from here. The first line, lookup table equal to this dictionary, then lookup table equal to this dictionary. Okay, now the thing is here, I should use dot update because it's not updating the old dictionary. Now it's correct. Wow. So I hope you understood. So you create the lookup table, or you can just convert it to int if you want, and then I update it with Jack and Queen. Then I add hand score and number of aces. I go through each item in the hand. If the item is in lookup table, I increase the hand score using the lookup table. Otherwise, I increase the hand score by 1 and increase the number of aces that I have. Then I go through all the aces, and if my hand score plus 10 is less than equal to 21, I increase the hand score by 10. And then in the end, I return the hand score. So if hand is aces is 0, this loop is not going to run. Let's see the solution here. They also created a new function, but they have done it a little bit differently than me. So yeah, take a look at both the solutions and let me know what you think. And let's go to the course pages and see what we have here. So we have been doing Python. So yeah, Python is complete. I have a certificate. So yeah, now if you have finished all these 7 days, you will get a certificate. So I hope you like this video. You can download the certificate and share it to LinkedIn or Twitter. I'm going to share it. And I hope you like this video. And if you do like it, do click on the like button, do subscribe, tell your friends about it, and share it. Thank you very much. Goodbye. See you on day 8, where we start with machine learning. Bye bye.